In this introductory video, we'll go over what LabVIEW is, why we would want to use it, and what we can do with it. I already have LabVIEW installed, so I'll open that here now. When you first open LabVIEW, this is the interface you'll see. LabVIEW is an integrated development environment designed to accelerate productivity of engineers and scientists. LabVIEW is essentially a programming language, just like C or Python. Let's take a look at what LabVIEW looks like. The most basic element of LabVIEW is the VI. It's composed of two elements, the block diagram and the front panel. The front panel is what a user will interface to, and the block diagram is the code. If we look at the front panel, we can see all kinds of controls and indicators that we're able to add. Different elements for creating a visual user experience that we want. When we put down controls and indicators on the front panel, their associated terminals show up on the block diagram. In addition to control and indicator terminals, we can see all kinds of code elements that are very typically used in all kinds of programming languages. More specifically, we can look through a wide number of specialized VAs for all sorts of things, including mathematics, signal processing, data communication, external connectivity, and many, many more. We can look through the palette to find something specific. For example, if we look through here, we can find all the VIs required to engage in TCP communication with another computer. Another example would be looking through the mathematics VIs at probability and statistics and finding a full palette of VIs for calculating important statistical measures. Let's clear our block diagram of code and look at a real simple example. I'll bring up the palette by right-clicking on any open space on the block diagram, hover over the numeric function palette, and click this little pin to stick it to my window. I'm going to add some functions here arbitrarily: add, subtract, multiply, and divide. I do this by left-clicking on the function I want, dragging it over to the block diagram, and left-clicking again. Now I'm going to add wires arbitrarily between each of these functions. I do that by hovering over one of the terminals that is an output, left-clicking, and then dragging that over to another input terminal on another function. I'll connect these arbitrarily without too much thought. You can see that this is a little confusing right now and it's hard to follow the flow, but if I hit Control U, the block diagram will automatically be cleaned up. I'll take this and drag it over here so we can see it in the middle of our block diagram. Now I'm going to add a few constants, a control, and an indicator. I do this by right-clicking on input terminals and clicking either Create Constant or Create Control. And I do the same thing on output terminals by right-clicking and creating an indicator. I'm going to clean up the block diagram again and drag this back over. I can change any constant input number by double-clicking and changing it to the number that I like. And I can double-click on the control here, which will bring me to the front panel indicator, and I can change the number there arbitrarily. In text-based programming languages, programming execution happens in order, from top to bottom, as you cycle through lines of code. LabVIEW, however, follows something called the data flow paradigm. What that means is that each function will wait to execute until all of its inputs have received their data. You can see that for this multiply, I have two inputs, the constant 5 and the control that I've also connected. But if I look down here, the input to the subtract is the output of the divide, and the input of this divide is the output of the multiply. And so this algorithm will happen in order. The multiply will have to happen first, then the divide, and then the subtract. There is never a situation in which this subtract will execute before this multiply, because it's dependent and waiting on data to come in. This highlights one of LabVIEW's strengths, but also something you have to watch out for: its inherent parallelism. This portion of code and this portion of code can be executed simultaneously because their inputs do not depend on each other. This portion of code, however, has to wait for both of these trees to be completed before it will execute. I'm going to close this palette window and give a visualization of this. By clicking the Highlight Execution button, We can slow down execution and follow the data as it travels through the wires to see how LabVIEW executes. I'll click the Run button and we'll see the data move through the wires. You could see in this case that the bottom branch executed before the top branch, and those both had to execute before the subtract was executed. Finally, we got our end result, -4.25. Like other programming languages, you can add execution structure elements, like while loops, for loops, case structures, which are like if-then statements, and sequence structures. This has been just a basic example of some LabVIEW programming, but you can imagine that with some imagination, all of the functions provided here, and the combination of a wide array of front panel elements, LabVIEW was designed specifically as an intuitive, easy-to-use interface to work with National Instruments hardware. In the remainder of these tutorials, we'll focus very heavily on data acquisition, collecting measurement data, and interfacing with real-world hardware devices. In order to do that, we need to learn a little bit about the project. I'll close this VI, I don't need to save it, and that will bring up again my LabVIEW interface. If I go to File, New, I can select a blank VI or an empty project and create that. The project is a repository saved on your hard drive where you can organize your code. VIs can be stored within projects, as well as a number of other elements and interfaces that you'll find useful in your programming journey. We'll talk more about the project in future tutorials, but it's important to understand that most of your code will be organized within a project, not simply VIs. We'll also go over how to use NIMAX, National Instrument software for finding, connecting to, and interfacing with data acquisition software.